We've got adding fractions. Why would I tell you to do what?
I thought you put them forward. Why would you put them into improper fractions and then make it a mixed number? How are we supposed to know that improper fraction is the number for it?
Convert your answer. I said your answer may be an improper fraction or a mixed number. I didn't care which one you finally ended up with. Okay, I suppose I could do it for you, because apparently that's a lot of work. So we've got 19/5. This one's going to be 41/6. This one's going to be... No, I think it's all of them. There's two. You were complaining about two. Oh. And sliding this thing down. Take a look. Comments, questions, concerns. Anything going on there that's you don't like or weird? Okay, I'm gonna flip the page. This is the last chunk. Which means you're probably not going to like 5.5, which means I have to give this as positive 11 over 2. Comments, questions, concerns on any of those? You reduce it, it has to be 11 over 2. Which question are we looking at? Number 6?
Oh, yeah, no, that's oh my god, no way.
Yes. Sure. Which number 6? This number 6 or this number 6? This number 6, okay. So I converted -1 and 4 over 7. Ooh, this is maybe where things get a little bit weird. I converted -1 and 4 over 7 into a improper fraction. So to do that, you got to be careful how you do that. It's not 7 times -1 plus 4. It's 7 times 1 plus 4, and that whole fraction is negative. So 7 times 1 is 7 plus 4 is 11. So I get -11 over 7. Same thing with this one. It's 2 times 3 plus 1, which is 7 over 2, and the whole fraction is negative. So I've got -11 over 7 times -7 over 2. And then I simplified it first. These are both, 7s are both divisible by 7. So that becomes -11 over 1 times -1 over 2. 11 times 1 is 11. 1 times 2 is 2, and the two negatives multiply and make it positive. Yes, that is where the mistakes frequently get made. What you have to remember is that whole fraction is negative. So you want to deal with it like this. I guess if you're thinking about it like that. Convert it to an improper fraction from a mixed number, assuming that the negative isn't there, and then put the negative in there, because it's the whole thing that's negative, not just the 1. Any other comments, questions, concerns? Somebody asked something about going over dividing fractions again, but I mean, it's pretty, I don't know how to go over it again. Like you take the second, when you divide by a fraction, you just take the reciprocal of the second fraction, and then division becomes multiplication. So 1 over 2 becomes 2 over 1, and division becomes multiplication. That's it. That's all you got to do. If you want more than that, you need to let me know, because I'm not totally sure what more you want. But that question did come up, but that's all I've got for you. So if there's further questions about dividing by fractions, please do let me know. Something you should have gone over a bit last year. But who knows what COVID did to middle school. But anyway, flip the page. Let's keep going. We're going to look at fractions, percents, and decimals. Ooh, just calm down there. Plexiglass. Okay, so again, this is something you should have done way back in the past somewhere, and some of these things you just kind of have to know and remember. You're going to be able to do a lot of these longhand if necessary, but I want to see how many of these are just kind of buried somewhere in the past. So if I have 3/4, what is that as a decimal? 0.75. How'd you do that? How do you know? You just remembered, and it's common sense. Okay, if it wasn't common sense, if you have to explain this to my daughter who's 1, how would you explain that to her? Yes, sir.
You divide the numerator by the denominator. Or
So
the top number by the bottom number.
So you divided 3 by 4?
Yeah.
Like in your head?
No,
No, you don't get a calculator. You don't know how to do that with a calculator. Okay? Kyla. Sorry? With long division. You want to do it long division style. We can do it long division. If I divide 3 by 4 long division style, how many times does 4 go into 3? It doesn't. So we're going to add a decimal, add a 0. How many times does 4 go into 30? 7 times, because 7 times 4 is 28. That's a 2, add a 0, drop it down. How many times does 4 go into 20? 5. So 4 times 5 is 20. There's nothing left there. Okay, you can do it that way. How else do people do it? There's another way to do this. Do you have to explain to someone without using a calculator? Yeah?
Multiply y by 25.
Why are you multiplying 25?
Because 25 times 4 is 100.
Okay, so you want to multiply this by 25.
Yeah.
And this by 25, which is going to make this thing 75 over 100. Sorry? Okay, so then 75 over 100. That makes this division really, really easy, because when you divide by powers of 10, you just move the decimal as many times as there are zeros. So that works. I like it. How about 35 over 2? What is that thing as a decimal? How would you do that? I see a hand, Carolyn.
17.5.
How'd you do it?
I think divided 2 and 35.
So how many times does 2 go into 35? You said 17?
Yeah.
And how much is left over?
1.
So effectively what you did, in your head, you converted this thing into a mixed number. It becomes 17 and a half. And we know what our halves are, yes? A half is 0.5. So that 17 and 1/2 becomes 17.5. This fraction is what becomes the decimal. Cool. How about this one? (12/5). What would you do with that? Well, Carolyn, I know you know what you would do. You just did the last one. You're going to do this one the same way. How about someone else? Okay, let's put a pause on that for a second. I'm going to go up to the top here, and I'm going to ask, what fractions do you guys know that you can easily convert from fraction to decimal? Which ones have you memorized? Danny.
3/4 and 1/2.
Okay, so you know a half is
Stuff that
0.5.
makes sense in 100, if that makes sense. Like 1/2 is 50 cents out of 100.
Okay, so you make the dollar transitions. Okay.
Yeah.
Half of a dollar is 50 cents. How about just go straight to the base fractions here. Like you've done 3/4, so you guys should be able to do 1/4, yes? 1/4 is 0.25. So if you want to go bigger, if you want 3/4 and you know what 1/4 is, you can just multiply this by 3, yes? 0.25, 3 times 0.25 is 0.75. What other fractions have you memorized or been forced to memorize over the course of the last however many years? Yeah, Kyla. Sorry? 1.3? What do you mean? 1 over 3. Okay, cool. What's a third? 0.3. Continuing on. Repeating. So we put a dot above the 3 because it goes on forever. So 1/3 is 0.3 repeating. Then the 2/3 should be easy, right? Because what's 2/3 then if 1/3 is 0.3 repeating? Yeah, I just double this one. So that's going to be 0.6 repeating. There's an interesting proof here. Let's go one further. What's 3 over 3? 0.9 repeating. So here's interesting. 3 over 3 is 0.9 repeating, but you also know that 3 over 3 is 1. So how can 0.9 repeating be 1? No, you don't round it. There is no rounding involved. 0.9 repeating is 1. They are equivalent. There is no rounding going on. You have an infinite repeating decimal is equal to a whole number. That should make you a little bit uncomfortable. Next one, what other fractions do you know? Yes. The eighths. Ooh, you know your eighths. What's an eighth? 125, which incidentally is half of a quarter. So we know our eighths, so now we can just multiply our way up. So while 2/8 is a quarter, 3/8 is going to be a quarter plus a half. So you can, if you know your 1/8, you can go up relatively easily. What else do we know? There's a couple more fractions that I hope you know. Yes. Sorry? The tenths? Ooh, we like the tenths. What's 1/10? Yeah, 0.1. So then 2/10 is going to be, yeah, see, it's nice and easy. There's one other one that I would kind of expect you to, oh, there's two more that I would expect you to know. Yeah. The fifths, yes. I want you to know the fifths. I have no room. So I'm going to go back this way. The fifths. What is 1/5? 0.2. So then 2/5 is going to be double that, which is 0.4. 3/5 is going to be 0.6. 4/5 is 0.8. Okay, cool. There's one more that I hope you know. It's a nice, easy one. Yeah. That would be 1. It's a good one. It's an important one to know. There is a different one. Yeah, Kyla. No, the sixths are kind of gross because you have to take half of a repeating decimal. I mean, you could do it. 1/6 is 0.16 repeating, which is going to make 5/6 weird. But yeah, no, I don't expect you to know your sixths. I definitely don't expect you to know your sevenths, but I do expect you to know your ninths. Hands up if you know your ninths fractions as decimals. What? Okay, well sometimes my Predip 9s know it, sometimes they don't. The ninths are really easy, which is why I want you to know them. 1 over 9 is 0.1 repeating. 2 over 9 is 0.2 repeating. 3 over 9 is the same thing as 1 over 3, which is 0.3 repeating. And they just kind of go on forever. 4 over 9 is 0.4 repeating. 5 over 9 is 0.5 repeating, and so on, and so on, and so on. So 9 over 9 is 0.9 repeating, which is also 1, which is interesting. Because 9 over 9, anything divided by itself is 1. But it's also 0.9 repeating, which means those two have to be equal. So using these things, the base ones that I'm hoping you do know, your fifths, your halves, your quarters, your thirds, the eighths are nice, not as necessary, but nice to know. Your tenths, you definitely need to know those. Your ninths is just handy. The converting fractions to decimals can get a little bit easier. If I have 12 fifths, let's do what Caroline did before. She took your improper fraction and made it a mixed number and converted that to a decimal. Whether or not that's what she said, that's what she did in her head. So what's 12 fifths as a decimal? 2.4. How'd you do it?
I goes into 120 times. So then I multiply 12 by 20.
Oh, okay. Interesting. So then you got 120 over 100. No, what? 240 over 100. Interesting. That's one way to do it. And you move the decimal place. That's one way to do it. I like it. Multiply top and bottom by 20. So that becomes 240 over 100, which becomes 2.4. Anyone have an alternative way to do that? Perhaps using what we've written along the top of the page. Well, I could turn 12 fifths into a mixed number, yes? If I turn that into a mixed number, what do I get? Two and 2 fifths. Cool. And what is 2 fifths? Well, 1 fifth is 0.2, so 2 fifths is going to be double that, which is 0.4, so that's going to give me 2.4. There's all sorts of techniques for this. You guys are pre-diploma. I'm not going to tell you how to do it, but you've got to figure out any one of these techniques will work for you. Multiplying so that your denominator is a power of 10 is a really effective way to do it. Taking a improper fraction, making it a mixed number with a fraction that you know how to deal with, also a really great way to do these things. If you're really stuck and you just want to make the Hail Mary, no time left on the clock, throw up into the end zone and see what happens, you can long divide these suckers. You can always long divide these things. You take the top number, you divide it by the bottom number. Either by using long division I don't know why I put a comma there. Should have been the word or. A calculator if I let you have one. But I'm not going to let you have one for a while. Another option is to change it, or change the fraction to be over a power of 10. So 10, 100, 1,000, and then it becomes easy to divide, I hope. Or the other thing that we did here, make improper mixed and use the simple fractions. Lots of you guys have all sorts of techniques for this. I'm not going to tell you which one to do all the time. In fact, the one I will tell you not to do all the time is rely on your calculator. Because if you get good at this stuff, you'll often be faster than someone on a calculator. What if I want to go the other way? I want to take a decimal and I want to turn it into a fraction. This is arguably easier. How do I do this? Yes, sir?
You multiply by 100, so you make the decimal place 2 times 4.
Is it always 100? So if I have 0.5, do I have to multiply that by 100? I mean, I could, but do I have to? What could I multiply instead? I can multiply by 10. Because that would be enough to move the decimal place behind my digits, yeah? So it's not always 100. And if I had something like this, would multiplying it by 100 be enough? No, because I want to move the decimal all the way to the back, and multiplying it by 100 is only going to move it to here. But we're on the right track. What do I want to... Instead of saying multiply the decimal number by 100, what should I say? Yeah, Ty. A power of 10. Good. You want to multiply by a power of 10 over a power of 10. And they've got to be the same. And then you want to reduce that thing to lowest terms. How do you know which power of 10 to use? Which is what goes in this blank here. Well, you want to use the power of 10 where the zeros equal the number of decimal places. So if I have this guy here, there are 2 decimal places, so what power of 10 am I going to use? Use 100. So I'm going to multiply this thing by 100 over 100, which is going to give me, that moves twice, it's going to give me 25 over 100, and now I reduce. 25 over 100 is 1/4, because 25 goes into 100 4 times. That's one of the easy ones. What about something like this? I have 1.2. How do I convert 1.2 into a fraction? What power of 10 am I going to multiply by? Why 10? Who said 10? You're right, but why? Okay, so 1's the whole number. So it's 0.2. So there's only 1 decimal place there. So we multiply by a power of 10 with 1 0. Okay, cool. So we're going to multiply this thing by 10 over 10. If I multiply this thing by 10, what am I going to get? I get 12, and then it becomes 12 over 10. What do I do with that thing? Now I reduce it. If I reduce it, what am I going to get? 6 over 5. That is a reduced fraction. That is a totally acceptable final answer. There are those of you out there who don't like improper, so if I wanted to take that thing one step further and turn it into a mixed number, what would I do? It would become 1 and 1/5, because 5 goes into 6 one time and I got 1 left over. How about this guy, 0.175? I multiply by 1,000. Why? Who said that? Harlan, was that you? You're correct. Why do I do that? Yeah, I need to move the decimal 1, 2, 3 times. So I'm going to multiply this thing by 1,000 over 1,000. And I'm going to get 175 over 1,000. Okay, cool. Now what do I do? It's kind of gross, isn't it? I'm going to reduce it. Okay, 175 and 1,000 are both divisible by what number? Sorry? They're both divisible by 5. Cool. It's not going to be easy, but we can do it. 1,000 divided by 5 is? Sorry? Say that louder. 200. I can't see mouths move, so I don't know which of the 4 of you that said that. But that is ultimately correct. Because 100 divided by 5 is 20, so 1,000 divided by 5 is going to be 200. Now this one is the gross one. What's 175 divided by 5? Sorry, who's 35? Love it. How'd you do that, Harwin? Okay. I'm okay with that. I'm okay with not knowing. But that's correct. Can I take it further? You betcha I can. 35 and 200 both divisible by 5. So 35 divided by 5 is? And 200 divided by 5 is? I heard 40. Cool. So it may have been easier to divide by what to start? 25. But we didn't necessarily recognize that. Because to divide this thing by 25 is actually a lot easier to do in our heads. Because you could do 100 divided by 25, which is 4. I'm seeing fingers. And 75 divided by 25, which is 3. I'm seeing fingers. And 3 and 4 is 7. So I could go straight here and divide by 25 to get 7. And then 1,000 divided by 25, that may be a little bit hard. But 100 divided by 25 is 4. And I've just got one more 0. So 1,000 divided by 25 is going to be 40. So maybe that would have been a little bit easier for you. You've got to find a way to be able to do this without the calculator, because I'm not going to let you have a calculator. Cool? Next one, percentages. Percent means what? I think you've already told me this semester. Per 100. From the French, because this means 100 en français. We want to divide the percent by what? If it's out of 100, I want to divide by 100 to represent it as a decimal, and then the two forms become equal. So 15% is what? Sorry? Give me the intermediate step first. How do I go from 15% to 0.15? So that's going to become 15 over 100, which is 0.15. Because I'm asking you to go from a percent to a decimal, I don't need to reduce this thing. I want it to be out of 100. How about this guy? 5%. 5 over 100, which is going to give me what as a decimal? Sorry? 0.05. Because to divide by 100 means I move the decimal place to the left twice, and I fill in any empty spaces with zeros. So I'm here and I go 1, 2, and that empty hole gets a 0. So 5% becomes 0.05. And then 100% is just 1, because that's just going to become 100 out of 100, which is just 1. Cool. So the shortcut you guys already know, dividing by 100 is the same thing as moving the decimal place 2 places to the left. So we can shortcut this a little bit. 55% is going to be what? 0.55. 7% is going to become 0.07. And 240% is going to become 2.40, which I don't have to write as 2.40. I could just write that as 2.4. I don't have to have that 0 there unless I'm doing rounding and I tell you I want it to a specific place. Comments, questions, concerns on any of this? Is this ringing bells of time long gone by? Okay. Writing decimals as percentages. We go the other way. To convert a decimal to percent, we multiply by 100. Okay, cool. So 0.34. What's that? Oh, let's just do the shortcut right away. Let's just move the decimal place. How many places? Which way? 2 to the right. Love it. So 0.34 becomes 34%. Cool. 0.08 becomes 8%. 2.1 becomes 210%, which is exactly the same as all of these things down here. Cool. You guys can do that. Love that. It's important to include the percent sign. If you're converting from decimals to percentages, 0.34 is not equal to 34. It's equal to 34%. Just like units, including the percent sign is important because it completely changes the meaning of what you've got. Okay, the last combination of things is percents as fractions and fractions as percents. How do I do this? I can't tell you how many times someone says, well, what's my percentage? Well, you just got the test back. You tell me what your percentage is, but that's okay. How do you go from percents to fractions? The easy one. Put it over 100. Then do what? Then simplify or reduce. So 25% is what as a fraction? 25 over 100, which is going to become 1/4, I heard. Cool. How about 5%? It's going to become 5 over 100. What is that as a reduced fraction? I divide top and bottom by? How'd you do that? I divide top and bottom by 5. Okay, cool. Which is going to give me 5 divided by 5 is? 100 divided by 5 is? 20. Be careful. And then 35% is? 35 over 100, which is going to become what? 7 over 20. Cool, because both of 35 and 100 are divisible by? 5. Cool. Last one, writing fractions as percents. We want to write the fraction as a decimal by dividing the top number by the bottom number, then moving the decimal how many places to the right? 2 places to the right. And throwing down a percent sign. This is the one that always tricks students up. So if I have 5/6, that's gross. I told you didn't need to know your sixths fractions. Do I give you any of them in here? I don't. Do I? No, I don't. No, I don't. Okay, cool. So I'm just going to give you what this first one is. For the sake of this question, I'm going to tell you that 1/6 is 0.16 repeating. So if you're ever unsure, if I don't give you a calculator, as long as you know the base fraction, everything else becomes a little bit easier. 5/6 is just 1/6 plus 4/6, which is 0.16 repeating, and 4/6 is what? 4/6 is just what other fraction? 2 over 3, and 2/3 is what? 0.6 repeating. Cool. This is going to get ugly, so I'm just going to tell you that this is going to be 0.83 repeating. I will not require you to know your sixths. If I do, I'll have given you a calculator. So then what is 5/6 as a percentage if it's 0.83 repeating? Oh, you have a different question. Okay, Nika, yeah?
If it's 0.83 repeating, does that mean 0.8333 or 8333?
Good question. 0.83 repeating. The way I wrote this, I put a dot over the 3, and that notation means that it's 0.83333333333333. If it were 0.83838383, I would have put a line over top of the 8 and the 3. Is how that notation gets used. So then to turn this thing into a percentage, I multiply, or I do what to this decimal place? I move it 2 to the right, or I multiply by 100, and this thing is going to become 83, but what happens over here to the right? It's not a 0. It's going to become 0.3 repeating, and that's going to be my percent. Because this repeating means these 3's keep going. And so it's not just 83%, it's 83.3 repeating percent, which are different values. We started with a gross one. Let's do a little bit of an easier one. 2/5. Carolyn. Love it. Comments, questions, concerns on how she did that? Yes.
After that, do we have to put the 40 in at 100 or can we just put the percentage?
You could have skipped to the percentage because the fifths are ones that I do kind of expect you to know. So 2/5 is 0.4. And then you move it twice. It's a 0 there. You could have done it that way as well. And then everyone knows there's 17th fractions, right? Yeah, totally, right? Grab a calculator. Grab a calculator. We're going to, on something as gross as this, I'm going to tell you to grab a calculator. We're going to divide the top number by the bottom number. I mean, I could get you to long divide this thing, but it's awful. What's 32 over 17? What's 32 divided by 17? 88235. Keep going. 2941. Does anyone's calculator go further? Oh, really? Yours goes further? 2941. There's another one. So it goes 117. 6. But you can't access it on your calculator. Nice, I love it. The only one whose calculator might go further is Presley's, but because you had the fancy graphing calculator, didn't you? Yours can go further? How can it go further? Oh, you've got an arrow. I love it. Okay, we're not going to get you to go further. I love that your calculator can. What then is this thing going to be as a percentage? Sorry? Someone commit and say it loudly with a strong voice. 188.235, wherever and then now we have to talk about rounding. Let's round it to those 3 decimal places and we'll call that your percent. 188.235%, which is weird. It's never been a thing that'll ever happen. Comments, questions? Is this bringing back memories of things you've done before? Kind of, sort of. It should, a little bit. I'm hoping it does. Okay, so what I want you to do is I want you to flip the page. And I want you to do all of what's there. Lots of practice converting fractions to decimals, decimals to fractions, percents to decimals, decimals, percents, percents to fractions, fractions to percents. And if you haven't done it already, there's a bunch of rounding practice I want you to do again. Some of you did it a couple days ago when I handed things out upside down. Some of you did not. That's what I want you to work on. The photocopier is still down, so I don't have the square root stuff, but we're going to start that on Monday. Which you don't know is coming, but we're going to do roots next. It's going to be great. Square roots, cube roots, fourths, fifths roots, exact values, estimates. It's going to be awesome. Some of that you've definitely done before, some of that you've definitely not done before, and that's cool. So that's what I want you to work on for what remains in class. Let me know if you need a hand. I'm happy to assist.